Hello viewers, welcome to Bhadra Academy. Once again we are here with the CUET undergraduate program video for you, and today we are going to discuss about the very famous Kirchhoff laws. Also you can see our number in the screen where you can contact about the CUET undergraduate program and answer your queries about the course structure, fees and other details. So let's begin with our topic of Kirchhoff laws. So basically the Kirchhoff laws was given by the German physicist named Gustav Robert Kirchhoff, and he has given basically the two laws, right, where one by one we are going to see. And the very first law is the Kirchhoff's voltage law, right, which is also known as the KVL, which is also named as the loop rule, where we can see a circuit, right. So a current circuit can be analyzed by the Kirchhoff laws, and by the loop rule and by the voltage law we can see that the algebraic sum of the changes of potential around any closed loop involving resistors and other cells in the loop is exactly 0. In other words, we can say that the sum of voltage around any closed loop is 0. It means that if we take the voltage drop of all the resistors connected in this loop, so the algebraic sum of the total voltage drop will become 0. That is VAB, VAB, VBC, VCD and VD. Okay, so this is where the algebraic sum is given by this equation, where we can see that the total voltage drop of the circuit should be equal to 0, right? Also, along with this, there is the second law, which is known as the Kirchhoff's current law or the KCL, where it is also known as the junction rule. And in this junction, the total algebraic sum of the currents, that is incoming and the outgoing currents, are both equal, right? So incoming currents and outgoing currents are both equal, and therefore the algebraic sum, again if we take, it should come as 0. So in the words we can see that in any junction the sum of the currents entering the junction is equal to the sum of the currents leaving the junction. In other words, we can see that in a circuit the sum of the current flowing into the junction is equal to the sum of the current flowing into that junction. So the algebraic sum we can give by this equation, where we can see I1, I2 and I3 are incoming currents, right, and I4 and I5 are outgoing currents. And if we take this in this side, so we will have an algebraic sum, that is I1, I2 and I3, and this will become negative, that is outgoing currents I4 and I5, and the total sum will be 0, right. So in this way we can have the two Kirchhoff's laws, and these laws are very useful to analyze the electrical circuits of the current electricity, right. So it has a various applications and the foundation of current electricity. So I hope that you have understood the topic, today's topic. So similar videos we are going to bring it for you. Be with us. Thank you so much.